Hello and welcome. Today we are here to discuss the question from lead code, which is question number 674, a longest continuous increasing subsequence. So we'll go through the question, we'll read it, understand it, and try to solve this question. So given an unsorted array of integers nums, return the length of longest continuous increasing subsequence. Therefore, a subarray. Okay, the subsequence must be strictly increasing. The subsequence must be strictly increasing. A continuous increasing subsequence is defined by two indices L and R, L less than R, such that nums of L plus 1, R minus 1, nums of R, and for each L less than or equal to I less than R, nums of I is less than nums of I plus 1. So it should be a continuous increasing subsequence. So they have also given an examples. Example 1, nums equal to 1, 3, 5, 4, 7. Output is 3. Output is 3. Why? What is that 3? These three elements are in these three elements are the longest continuous increasing subsequence with length 3. Even though 1, 3, 5, 7, we have 1, 3, 5, 7, but it is not continuous. Okay, so the point is we should have a continuous increasing a subsequence, and increasing it should be strictly increasing. Okay, so coming back to this, just okay, coming back to the question, guys. The question is we need to find out. So they'll give us an array. Okay, they'll give us an array 1, 3, 5, 9, and also 7. They'll give you an array like this. Now, from this given array, okay, this array is an unsorted array. This is not an sorted array, guys. This is an unsorted array. And from this array, we need to find out a subsequence. This can also be a subsequence. This can also be a subsequence. This can also be a subsequence. So we need to find out a subsequence, okay, where it is a strictly increasing. It should be a strictly increasing, and we need to find out the length of longest continuous increasing subsequence. Okay, first thing, let's go step by step. We know what is subsequence. Okay, now increasing subsequence. What is increasing subsequence and strictly increasing subsequence? So as you know, subsequence is any part of the array. Okay, now increasing subsequence is not in the sense. So if we take this subsequence 1, 3, 5, what are the elements we have? 1, 3, 5. Okay, all these are in increasing order. The array is in increasing order. If you see the order of these three elements, 1 is okay less than 3, and 3 is less than 5. They are in increasing order. Okay, and strictly increasing. Why this is okay? This is a strictly increasing subarray or subsequence. So why? Because all, if you take any two consecutive elements, they are strictly in increasing fashion. Strictly in increasing fashion. Why strictly in increasing fashion? If I'll take one example which is not strictly increasing. 1, 3, 3, and 4. 1, 3, 3, and 4. Now this is in increasing order. Okay, this array is in increasing order. But this array, okay, whatever the array that we have taken, this array is in increasing order. But is it strictly increasing? Is it strictly increasing? No. Why? Because if I take any two elements, let's say 1 and 3. Okay, 1 is less than 3. Okay, this is true. And now if we take 3 and 3, 3 and 3, is this 3 less than the other 3? No, right? So this is not an increasing, strictly increasing subsequence. Okay. This is not an strictly increasing subsequence. So I hope this subsequence, increasing subsequence is clear. An array, a subarray, or a part of the array which is in increasing order, and it strictly in the sense we don't have duplicate elements. Simply, or to be precise, where that subsequence doesn't have a duplicate elements, consecutive duplicate elements. That is what you can simply think of. Or if you pick any pair of elements any two continuous elements, there should be the two elements should be less than, like the left side element should be always completely less than. That is what the condition given here. Nums of I should be always less than nums of I plus 1. I plus 1. So I will be 0 and I plus 1 is 1. So these two elements should always be strictly less than. That is what the strictly is. Continuous, it should be a contiguous array. And longest means we have here 1, 3, 5 and okay, 1, 3, 5 is a subarray where the length is 3. And we also have 1, 3, 5, 9 where the length is 4. Which is the longest increasing thing? We need to return the longest one. We should not return the shortest. We should return the longest. So answer should be 4. This is what the longest is. I hope this question is clear. Now let's jump on to the thinking approach. So what will be the brute force approach, guys? What will be the naive, the basic level approach that you can think of? So the brute force approach for this is like just go to each and every element and check from this element, do we have this increasing order? From this second element, do we have this in increasing order? From this third element, do we have it in increasing order? From this fourth element, having it increasing order. Like go to every element and check on the right side whether is it in increasing order, what is the length. That's all. Pretty simple thing, right? This is what the naive brute force approach. But even they have given a clue in this question, LR, like they're using 2 pointers thing to find out this thing, like the subsequence, start and also end. There is a start and there will be an end for the subsequence. So we need to find out this particular subsequence and like we need to find out the length here. Anyways, moving back to our approach. So let me open this paint. So let's take an example. Okay. Nums equals to, okay, 1 second, guys. Nums equals to, okay, 3, 5, 7, 4, 5. Nums equal to 3, 5, 7, 4, 5. And the indexes of this array is 0, 1, 2, 3, 4. These are the indexes. Okay. Sorry. So these are the indexes. Right. Okay. As we discussed, the brute force approach will be go to each index. Okay, go to each index. Let's say I'll go to the index 0. I'll see on the right side what is the how, like till what level I go on increasing. So 3 and 3, 5 is 3 is less than 5 and 5 is less than 7. So this is one subsequence. Okay, which is in increasing order. Okay, which is in increasing order. Right. So the length is 3. Okay, I got one answer now. And again, what I will do, I'll go to index. I'll go to index 1. Again, I'll see 5 is less than 7. Then length is 2, which is my first length is 3. Okay, now I got answer as 2. And 7 is not less than 4. Now I got answer as 2. And I'll check with my answer. Okay, 3 is bigger one. I'll keep as it is. This is not my answer. Now I am at 7. 7 less than 4? No, not at all a chance. Now again I'll hit 4. 4 less than 5? Yes, true. And the length is 2. And this is not bigger than my 3. So I'll simply stop this process. And at the end, I have 3 as my answer. So I'll simply return this 3. So here if you observe, for every element, we are going on the right side and checking entire right side, and we are checking that what is the, like till what extent we can go and what is the increase, like whether that is increasing or not, and we are doing that particular approach. So for this approach, we don't have any space used, but the time complexity will be n square. Why? For every element, we are running an inner loop to check on the right side. We are running an inner loop. Okay, we are running an inner loop to check on the right side. So external for loop and internal for loop, which will be 2 for loops, and time complexity will be n square. This is what the brute force approach is. Now just think. Now just think for a second, guys. Now let's say this is increasing. Okay, this is an increasing subsequence. Now let me take a different color. Okay, even this is also an increasing subsequence, right? Yes or no? Yes, yes. This is also an increasing subsequence. Now, if you find this outer subsequence, is it necessary to calculate for 5 again? Is it necessary? I know already this is a subsequence which covers 3, which adds an additional value also. If this becomes a subsequence, obviously all the sub arrays of this particular subsequence, okay, all the sub-arrays of this particular subsequence will also be an increasing order, right? So once we find out this, we will not do for 5 and 7. We should not do for 5 and 7 because there is no sense of doing it, because we already know we are already in the longest subsequence, and why we'll obviously do that. So we'll simply go for 4 and 5. Okay, this is what we are doing extra there. We are finding out for every element, but once we got for 3, which is 4, 3, 5, 7, is it really mandatory to do for 5? No, right? Because 5 and 7, okay, if 5 and 7 has one more pair called 9, obviously this will come under 3 also. This would be covered under this subsequence also. If that is not covered, obviously for 5 also will not get covered, right? So that is what our logic is. So we need to find out a subsequence for the element 3. And once we find out the subsequent, we will simply skip the entire part which is covered by 3. And we'll go to the next half. That's all, guys. That is what the approach is. So we will take 2 pointers again, P1, and this will be my P2. Okay. Now I'll compare these two elements. 3 less than 5. Is this condition true or not? Is this condition true? Obviously, this is true. I'll simply move my P2 one step ahead because this is a subsequence where it is increasing. I'll check whether is there any possibility to extend my length. So now again, I have 7 and 5. Now I need to compare these two elements. So whatever the P2 is pointing and its before element Now what is the P2? 7. What is the before element? 5. Before element of P2, 5 and 7. Are they increasing? Yes. I'll move my P2 one step ahead. My P2 is pointing to 4 now. Now what is the element at P2? 4 less than symbol. What is the element which is one step before P2? 7. Is this condition true, guys? 7 less than 4? No, this condition is not true, which means I already got a subsequence. Now P1 is pointing to 3. P1 is pointing to index 0. Okay, P1 is pointing to index 0 and P2 is pointing to index 3. Whatever the elements which are there in between, inclusive of P1, this is a increasing subsequence. This is an increasing subsequence, right? I need to find out its length. How I'll get the length? P2 minus P1. I'll get P2 minus P1. Okay, I'll store this in an variable. Let's say ANS. AN is my variable. What is the answer now? Answer is 3. P2 minus P1. P2 is 3, P1 is 0. 3 minus 0, it is 3. Now, okay, I got this and subarray. Once we got this, is it necessary to check for index 1, index 2 again? No, right? Because these are already covered as part of P1, like 3 only. So now we don't need to check for this particular part. Now again, we'll move our P1 to this place. This is our P1, and here we will place our P2. Okay. Now P1 and P2. What is the value at P1? 4. Sorry, what is the value at? Sorry, guys. What is the value at P2? 5. What is the value which is one step before at P2? 4. Are they increasing? Yes, they are increasing. So move your P2. Okay, we will move our P2, and our P2 reached end of the list. Our P2 reached end of the list. Now we still need to process the answer because our P2 reached end of the list, but we haven't processed the answer for these two pair, right? We haven't processed this to answer for these two pair, 4 and 5. So after reaching the end of the list, we will come out of the loop and we will find P2 minus P1. Okay, let's say what is the answer I will get for P2 minus P1? We will get 2. Okay, we got 2. Now, should I directly update this in my variable answer? Should I directly do? No, right? Why I'll do? I need to find out the longest. I need to find out the longest one. Now, I can't directly say whether this is longest. I'll just compare with answer. Whatever the existing value is there, I'll compare with the new value. If this new value is greater than the existing value, then obviously I'll update. Now, what is the existing value? 3. What is the new value? 2. Is this 2 greater than 3? No. Why I'll update? I'll simply end this process. And then whatever the answer is there, I will return that particular answer. That's how we will solve this question. So the main point we need to understand here is, okay, the main point we need to understand here is, once we find out, okay, once we find out this is a subsequence which is increasing, okay, when we are at 3, we find out this is the increasing subsequence. And once we find out this particular subsequence, we should not iterate on this again. That is the main idea. That is the main idea behind this particular logic. I hope this is clear. Now let's jump on to the code. Let's try to solve it. Then I guess you will get a more clarity there. So this is the place. Give me a moment. Let's delete all these things. Let's just try to code this now. Okay. Right. What is the first step, guys? What is the first step? We have two variables, int p1, which will be 0. p2 will be 1. Okay. Now, what I need to do, I need to find out n, like elements in my list, n equal to nums dot length. Okay. Now I need to iterate. Now I need to iterate on my array till p2 is less than n. Okay. When iterating on my p2, okay, when iterating on my p2, what I need to do, I need to check. We need to check p2's value with p2 minus 1's value, right? p2's value and p2 minus 1's value, one step behind basically. So I'll check. How I'll check? If nums of p2 minus 1, okay, nums of p2. What I need to check whether this is in increasing order. How I can say whether it is in increasing order or not? If it is less than. If the previous value is less than my current value, then it is an increasing order. Yes, right, obviously. Then I'll simply increase P2. Okay, okay. That is an increasing order, we will simply increase. Let's say if they are not increasing. If they are not increasing. Now, what is the thing here? If they are not increasing, as we take this example, 1, 3, 5, 4. Now, 1 and 3. They are in increasing order. This is my P2 initially. This is my P1. Okay. Now 1 and 3. Are they increasing? Yes. I'll move my P2 one step. Now this is my P2. Now what I need to compare? What I need to compare? I need to compare this 3 and 5. How I'll compare? P2 is my 5. P2 minus 1, like one step before is 3. Are they increasing? Yes. Now again, P2 will move one step ahead. Now 5 and 4, are they increasing? 5 less than 4? No, right? Now this is not correct. Now what we need to do? We need to find out the difference. What is the length of this sublist? What is the length of that sublist? How we will find out the length of that sublist? So how I'll get the length of the sublist? So we will take int current length equals to P2 minus P1. P2 minus P1, and we need to declare one more variable here, which is int answer, which will be 0. Let's take it as 0. Now, after finding the current length, what I need to do, I need to check, I need to update my answer. Okay, I need to update my answer. Okay, let's do answer equal to current length. Okay, should I directly update my answer? Should we directly do? No, right? We should have the longest. we should get the longest one. So for that, what I'll check, if my answer value is less than current length, okay, if the answer is less than current length, then only we will update the answer. Then only we will update the answer. Is this clear, guys? We are not directly updating it. If my answer is having less length than the current length that I have, then I'll update the answer. After updating, what I need to do, let's say we have updated. Now, let's say that we have updated the answer. Answer will become 3. Okay. Now what I need to do, I need to check further, right? I need to check further, is there any longest subsequence? Now, if you take 4, 5, 7, 9, this is the longest. I need to find out this length also, right? Now, what I'll do, I'll move my P1 to this particular place. I'll move my P1 to this particular place where the P2 is being there. So this will be a new start again. This will be a new starting again. Now, this will be my P1 and this will be my P2, and I will repeat this process again. I'll repeat this process again. Is this clear, guys? Once I got subsequence, I have simply skipping this and I'm going to new place, completely new place. So how I'll do that? P1 will be moving to P2. P2 will move one step ahead. That's all. And after iterating of entire this, what we need to do again? We need to find the answer again. We need to find the answer again. Why? Because why we are doing this particular step? Okay, why we are doing this particular step? So let me take an example. We have already seen this example, but still, let me take an example again. So let's take this. So this particular for loop, let's say we have 1, 4, 7. 1, 4, 7 as the array. What is the answer here, guys? I hope you all know the answer. The answer will be 3. Right, this should be our answer. Now, this is my P1. My answer variable is initiated with 0. And this is my P2. Okay. What is the value at P2? 4. What is the value before P2? 1. Is 1 less than 4? Obviously, that is true. I'll move my P2 one step ahead. This is my new P2. What is the value at P2? 7. What is the value one step before P2? 4. Is 4 less than 7? Obviously, true. I'll move my P2 one step ahead. Now P2 is reached end of the list. Now P2 is reached end of the list. But are we updating that in the answer? Are we updating the answer? No, right? We are not updating the answer. Once P2 reaches the end of the list, we are not updating, but we still have this answer. But we still have the answer. So for that purpose only, we are finding this length again. And if that is less than, if the answer is less than the current length, then we are updating it. And then what we need to do, we need to simply return the answer. That's all. We need to simply return the answer. So now let's run this code. Okay, it is taking some time. Okay, this is accepted. Let's submit this. That's all, guys. This has been solved. So this is what the code is. I hope this is clear. Thank you.